This is where it gets really interesting for me, how software and hardware are changing an entire industry, mobility.
Yeah, we're moving way beyond just electric cars. The vehicle is rapidly becoming a software-defined product. Our sources show a, frankly, startling 74% of automotive executives believe that by 2035, vehicles will be predominantly software-defined and AI-powered.
And the really big takeaway for manufacturers is that brand identity itself is shifting. It's moving from the engine to the digital
That's
experience.
it, exactly. An overwhelming 75% of those execs say the software-defined experience will be the core of brand value by 2035.
Wow.
It just completely supersedes traditional things like horsepower or interior design.
But the infrastructure required to power that software it's terrifyingly dense.
When we talk about data volume, what kind of numbers are we talking about?
Staggering amounts. An autonomous vehicle, driven an average distance, can generate up to 4,000 gigabytes of data
Per day.
per day. This requires massive onboard compute power, and that data is the foundation for future value. Personalization, new services, AI insights for the driver.
To handle that kind of power and data, the hardware has to evolve just as quickly. So what's the underlying tech that's enabling this new class of EV performance?
It really requires a jump in efficiency. So we're seeing the adoption of 800-volt battery architecture up from 400. This is accelerating the use of silicon carbide, or SUNO power
And
modules.
Sonosine is just much more efficient.
Much more. It significantly reduces energy loss, which means better range and faster charging. And the competitive dynamic here is fascinating. Chinese OEMs are leading in vertical integration. They're controlling the supply chain right down to the semiconductor level.
Giving them a huge advantage in speed and cost.
A distinct advantage, yeah. But that mobile data center doesn't operate in a vacuum, right? It has to talk to the outside world, especially for safety.
That's where V2X vehicle-to-everything connectivity comes in. It uses a specific spectrum band, and it's crucial for safety applications, letting the car talk to traffic lights, the road, other cars.
And what are the goals for that rollout?
They're highly ambitious. The U.S. goal is V2X capability at 75% of signalized intersections in the top 75 metro areas by somewhere between 2032 and 2036.
Right.
That requires a huge nationwide investment.
And even smaller devices like e-bikes and scooters are part of this whole connectivity challenge.
Indeed. Look at light electric vehicles, LEVs. They rely on microcontrollers, power management units, traction inverters, usually at lower voltages.
Right.
And why this matters is because efficient component selection is absolutely critical. Every fraction of energy you save directly translates into more range and better performance. It's all about maximizing efficiency.